So this lesson is going to cover Unit 1920, boxes C and D. Box C here is derivatives of other trigonometric functions. So what we talked about in the first lesson in 1920 is we looked at the derivative of the sine function, and we looked at the derivative of the cosine function. Okay? And we did those two together because, well, sine and cosine kind of go naturally together. What was the derivative of sine x? If it was just cosine x, and derivative of cosine x was negative sine x. Okay, so we've got two derivative rules down. We got four more that we have to learn here. So by the end of today, we want to be able to do derivatives of not just sine x and cos x, but also tan x, cotangent x, and cosecant and secant. And the learning guide goes through how you would derive these things in terms of sine x and cos x. You don't need to be able to do that. You should look at it just in case that comes in handy. And we'll do one of the derivations here. We'll do the derivation of tan x. But really what you need to know for the test is you need to memorize these formulas and be able to apply them on the test. So in terms of remembering them, what you sort of have to realize is that sine x and cos x go together, kind of like what we've talked about up here. Cosecant and secant we're going to talk about sort of together, and tan x and cotangent x kind of go together as well. I'll just put some arrows like here. And what you have to do is come up with some way of knowing these 6 differentiation formulas so that when you get to the test, you can write them up on the top and then use them on the rest of the test. So this is how I kind of remember them. Okay? That's just what I've said there, the derivations and stuff. This is what I remember. If the function starts with a c, the derivative is going to be negative. It's going to have a negative sign in front of it. And we've seen that with the cosine function. Derivative of cosine is negative sine. Okay? And then I sort of grouped them together just the way I explained. Tangent and cotangent, both of their derivatives follow a pattern. It's something that is then squared. And secant and cosecant also follow a pattern. Their derivative is something times the function themselves. So secant is something times secant. Cosecant is something times cosecant. Okay, so I sort of divide them into these 2 categories. And then if I can remember one of them, I can sort of work out what the other ones are, just enough to get them onto the top of the test, and then I can go from there. So the one that I try to remember is tan x. Okay? And I've got this written on the top of the next slide anyways, so I'll just jump over to here. Because if I can't remember what tan x is, I can always derive it. Okay? And here, because it's pretty simple to derive. If we're looking at tan x, I know that tan x is sine x over cos x. So if I want to do the derivative of tan x, d by dx of tan x, I just have to use the quotient law and use these 2 derivatives that I already know, because I have no trouble remembering sine x and cos x. So if I apply the quotient law here, I need derivative of sine on the top, so that's going to be cos, times the bottom, which is another cos, minus what I have on top, which is sine, minus the derivative of what's on the bottom. Derivative of cos x is negative sine x. And all of this is divided by cos squared x, or the derivative of what's on the bottom squared. Well, then I can clean this up a little bit here. I get cos x times cos x gives me cos squared x. The 2 negatives gives me a positive, so I've got sine squared x over cos squared x. This I can simplify because, yeah, I've got that Pythagorean identity up at the top there, so that gives me 1 over, whoops, excuse me here. I only need 1 division sign there, 1 over cos squared x. Now, what is 1 over cos squared x? Well, we've got these handy-dandy trig formula sheets here. You get to have one of these on the test. So if you look at 1 over cos, you see that 1 over cos is secant. So my derivative here is secant squared x. So I said that the derivative of tangent was something squared. That something is secant. Okay. So there's my first rule, right? D by dx of tan x is secant squared x. What if I wanted to do the derivative of cotangent x? Well, I know it's going to be negative because cotangent starts with a c, so it's going to be negative something. And I know that, like tan x, it's going to be something squared. So what is that something? Well, with tangent, I had secant. With cotangent, I'm going to have cosecant. Because secant and cosecant kind of go together. Then we move along here. D by dx of, let's do secant next. I know that secant is going to be something times itself. So it's going to be something times secant x. What is that something going to be? Well, if I go back up the list, up here, tangent and secant kind of appeared at the same spot. So it shouldn't be a surprise that this is going to be tan x secant x, where those two are multiplied together. The next one down is cosecant x, which I know is going to be negative because it starts with a c. It's going to be something times itself, just like secant was. So I put this cosecant x at the end. And I just need to know what that something is. Well, if secant is tan x secant x, cosecant is going to be cotangent x times cosecant x. And just up above here, we had cotangent and cosecant. So if all you need to be able to do is write them down at the top of the test, you can sort of check that you got this pattern down after you've written them all out, and then apply them from there. Okay? So the only ones I can really remember are sine and cos, and usually I have to actually write out secant, cosecant, tangent, and cotangent again before I use them. Okay? So that's the strategy I would pursue on the test. Okay? So once you know them, the next thing you need to be able to do is apply them to find derivatives, especially if you're combining them using the chain rule with the derivative rules that we already have. So let's just take look at a couple of examples here. The first one we're going to do is cotangent x here. So our function is y equals cotangent of 2x squared minus 3. Okay, so a straightforward chain rule application here. We've got our outer function is cotangent. Our inner function is 2x squared minus 3. So just over here, just to refresh our memory here, we know that the derivative of, well, that's not what I wanted to write. We want to write, just to remind ourselves, what the derivative of cotangent x is. Okay, so it's cotangent. It's got to be negative. It's going to be something squared, and that something is cosecant squared. So our derivative here is of cotangent is negative cosecant squared. Okay. So how do we apply that here? Well, let's see. We need negative cosecant squared of whatever we have as the argument of that cotangent function. So we're taking the cotangent of 2x squared minus 3. So we want to have cosecant squared of 2x squared minus 3. And then because this is the chain rule, we want to multiply by the derivative of what's inside. So this gets multiplied by 4x. And there's our derivative. We could rewrite it negative 4x cosecant squared 2x squared minus 3, but that really doesn't make any difference. Okay. Right? So there's our chain rule. All right, our next example here. Y equals secant of cosecant of x squared. So how many functions do we have here that we're going to have to work with? Not just two, but three. So we got to use the chain rule twice, basically. So once again, I'm just going to think to myself, what are these derivatives that I need? So we'll say derivative of secant is going to be, let's see, what's derivative of secant? It's going to be positive. It's going to be something times itself. So secant x, and that something is tan x. So it's tan x secant x. And then derivative of cosecant is going to be, let's see, similar to the derivative of secant, but it's going to be negative cotangent x times something, which is itself, which is cosecant x. So these are two of the derivative rules that I need, and I need to put these together. So I'll just give myself a bit more space here. Move this guy down. All right, let's take our derivative. So what is our outermost function here? Nick, secant. So first thing we want is we want the derivative of that secant function. So we want tan x secant x. But instead of x, we want whatever we are taking the secant of. Well, we're taking the secant of cosecant x squared, so we want tan of cosecant x squared, okay, times secant of cosecant x squared. Okay. So we've done the derivative of that outermost function secant, making sure that our argument of that tan x secant x is the same as the argument of the secant. This in turn gets multiplied by the derivative of cosecant x squared. So derivative of cosecant is negative cotangent x, cosecant x. So we need cotangent x squared times cosecant x squared, because that original cosecant had x squared as its argument. Then we have to multiply this by the derivative of what's inside here, well, which is our x squared. So we multiply this whole thing by the derivative of x squared, which is 2x. Okay? So the function that we get is ugly when we get to the end, but again, we're just applying, once you've got these rules down, you're just applying that chain rule, step after step after step. Okay? Go ahead.
Why isn't it times 2x again? Because you're finding the derivative of one of the inside like cotangent functions, right? What about that cosecant function? Would that have another?
This one here?
Yeah.
No, because this whole thing here is the derivative of this thing in here, right? And this thing here, right? So it's the derivative of the secant, then the derivative of what's inside the secant, which is this, and then the derivative of what's inside there. Okay? So you only need it once, even though this suddenly appears twice. Okay? Because the derivative of cosecant has two terms multiplied together. That's what makes it tricky. Okay? All right. Let's try this last one here. Okay. 1 plus tan x over secant x. Okay. So I've got two trig functions in here. I'm just going to remind myself what the derivatives of those are. So the derivative of tan x is secant squared x. Derivative of secant x is tan x secant x. Okay. And now I'm combining those using, well, what differentiation rule am I using here? Quotient rule, yeah. So let's just apply the quotient rule here. So we want derivative of the top. Derivative of 1 is just nothing. Derivative of tan x is our secant squared x. That gets multiplied by what we have on the bottom, secant x, minus what we have on top, which is 1 plus tan x. That gets multiplied by the derivative of what's on the bottom. Derivative of secant x is tan x secant x. Let's make a nicer secant there, secant x. And all of this is divided by denominator squared, secant squared x. Yeah, so now we want to start simplifying this. So as Brody said, we can cancel out a secant everywhere. There's one there, one there. Remember when you're doing this that you have to have a secant in both of your terms. So sometimes it's easier to factor it out first, rather so you avoid not canceling something out that you can't cancel out. But if we cancel that out, we have secant squared x, okay, minus, and I'm just going to rearrange these, tan x times tan x gives us tan squared x, and it's going to be negative because we have this negative out front, and then we're going to have a minus tan x from negative 1 times tan x, and then we're going to have secant x on the bottom. Okay. We can simplify it one more step here. Okay. By grouping this together. This is actually another identity, which doesn't appear on your identity page, which I didn't realize when I was putting together this example. But secant squared x minus tan x just goes to 1. This is kind of like sine squared plus cos squared. So this ends up being 1 minus tan x over secant x. Okay. So clearly, you won't have anything in the guide or on the test that uses an identity that doesn't appear on that identity page. And if you want to use that identity page on the test, you can. Okay, Nick?
So if it was like cosecant minus cotangent squared, or cosecant squared minus cotangent squared, would it be 1, 2?
Instead of secant, yeah, instead cosecant and cotangent, I think so. Yeah. 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 So yeah, the reason I chose this one is just to emphasize that it is possible sometimes to simplify them using identities, so you should be aware of that. And I thought this one was kind of neat that you started with 1 plus tan x over secant x, and you ended up with 1 minus tan x over secant x as your derivative. But. Okay, so that's box C. Basically, you need to know those derivative rules. And let's